given the books.
Hello everyone and welcome in today's one of the first presentations of the second event day. Today we will be talking about the artificial intelligence mechanism that based on the universal systems that we developed for our purposes for developing the grand strategy games. So I can share with you some ideas, some examples and some issues with the solutions that we was facing with during the development process. But first, I think I should say something more about me. My name is Fabian Berda, and I'm the Unity developer, aka the C# programmer, since the 2017. During my journey, I was developed over 18 mobile games applications, where 2 of them was published by one of the most popular mobile game publishers, and reached over 100,000 active users. In my current company, I was participating in the development of Real Politics 2, Real Politics 3, what we are currently working on, Punk Wars, Virus the Outbreak, and the arcade game, not the strategy one, the arcade game Flashout 3, dedicated for the PC platforms, and also I was responsible for the whole process of porting this game to Nintendo Switch console and the communication with the Nintendo. So the second part of this task was the hardest one. Okay, let's start with the example with the GTA Grand Theft Auto series as an example, because I want to say something more about this. What exactly is the modularity and universalism when the developers say something like, okay, let's make it modular or let's make it universal so we can use it later in the different productions. So let's take a quick look at the GTA series as a starter. In Grand Theft Auto, since the beginning, we had the driving mechanics. Are true in part 3, we only had cars. In Vice City, motorcycles, ice cars, and helicopters were added. In San Andreas, this was expanded to include airplanes, bicycles, and a rocket pack. Yeah, the last one, the most enjoyable. Finally, in GTA 5, we have submarines and trains as well. So we can see here this one basic driving mechanic expanded more and more within each installment. We get more and more vehicles to drive. In addition, we have traffic. The basis is the same everywhere, but it is getting more and more developed. That is, we have blinking lights, pulling over, etc. Accidents are also becoming more and more realistic. At the beginning, the cars only burned. Then we have a simple damage system. In San Andreas, it was already more developed. And in GTA 5, there's already a very realistic systems. Our cars are getting scratched and dented, more or less, depending on the impact of the crash. Even glass in our car can break, something that in Cyberpunk 2077 was, in example, leaked. San Andreas also added customization, which was later expanded upon in GTA 5. The 5 series also brought us the ability to possess a car which showed the fear that it will disappear after once abandoned. Shooting mechanism, with every game more and more developed from a simple point and press through simple aiming to quite realistic but easy to control recoil in GTA 5. The sheer number of weapons also have been changed with every game. Every new installment brought us more weapons. The damage system was also improved with each series, from the sponge-like enemy who just absorbed the bullets and their HP just dropped down to 0 or below 0, to the simple destruction between shots, all the way to the gun falling out when the shot in the hand and falling down after being shot in the leg. We also have an added shielding system and a change in the mechanics when the player aims from the car. And now the clue of this game, missions. In fact, since the GTA the third, they look the same. Come to place, follow someone by car, follow someone by foot, kill someone, lose a chase, or destroy something. The thing what adds the fun and enjoyment in these missions is the right configuration of these several mechanics mixed with content. Let's take a look at the side activities. Taxi, fire brigade, police, ambulance, each consisting the same mechanic as the main. Missions. Police, destroy, kill. Fire brigade, shoot water on the fire. Taxi, get to place. Ambulance, get to place. Races, get to place, but first. Dating. Pick up any previously mentioned mechanics to improve relationship. In GTA 5, what do we have more? Hunting. Kill an animal, relationship, dating, tennis, and golf. Yeah, it's kind of lovely, generic. Let's go back to the mechanics in the series. The main character, we have got the outfit change in Vice City, a hairdresser, tattoos, and gym, and exercises. In San Andreas, that can change the entire appearance of the character. In GTA 5, it looked like some of these mechanics weren't suiting them, but since it was a series, they couldn't give up everything. So we still have hairdresser, but much poorer. We have tattoos, but less numerous. Dressing is similar, but exercises was just thrown out. That is, they cut the changing figure of character. Instead, as you can see, we have 3 characters, and we are left with the skill development, but in GTA 5, it is very conventional and artificial. There's no realistic progression here, as it was in San Andreas, for example. Fighting systems were also abandoned. Let's look at the shopping. At the beginning, we could buy only garages, then real estate properties that gave us missions or money. In San Andreas, there are more hideouts, and in GTA 5, they gave up on them, so that's one mechanic that was continuously developed. But let's be honest, for what? The ability to save the game, enter a building, which means firing up another scene, acquiring money, which means picking up a marker to get money, or launch the next mission. In GTA 5, there's vehicle ownership, but with the pre-existing garage mechanics, that's not a big breakthrough. Buying clothes without customization of characters, there's not such a big change. The buying of weapons available in every game, only GTA 5 customization was possible. In San Andreas, we had the purchase of food approach. Press the button, lose money, and restore your health. Most of these games consist of similar set of mechanics, which each series more and more refined, and better mixed or configuration by the designers. So what is the idea behind the universal mechanics? Creating universal systems, in example mechanics that will be used in several games, created at once with the idea of fitting into several productions, greatly simplifies the work and speed up the whole process sometimes. Or true, it requires more commitment in the first stage. It also introduces certain limitations, which bypassing required much more creativity from the designer's side. Sometimes it may turn out that just using this approach, it will take more time for designers, but in overall we still have the same budget because there is a differences between the salaries of the designers and the programmers. As part of this presentation, I like to give you an example of constructing such a mechanic by presenting the construction of an artificial intelligence system for grand strategy games. One might wonder at length on the similarities of the various grand strategy games, but I think the best example of the fact that these games are used the same mechanic would be to point out the technology created by the main producer of this kind of games, Paradox Engine, with the really lovely name Clausewitz. In general, these elements work virtually the same in every grand strategy game. We always have the creation of terrain, world map. This is the main point where the player can interact with. Display of provinces, division the world into regions and countries, parameters. This is the core of the game because all strategy games have a lot of parameters. In example, economic, social, political, military, countries, provinces, relationship, etc. Interaction between the parameters, technology trees, camera mechanics, event, country relationships, building construction, and at the end, finally, artificial intelligence, which will use all of these above mechanics. It will have the ability to analyze all the parameters and perform actions on its own, which will use the player's decision during the events and behave towards them in a certain way. What is the difficulties in designing the grand strategy game. The fundamental problem with the development of multi-actor real-time grand strategy game from the technical side is achieving a good performance, especially on the mobile devices. This involves excessive use of computing power and memory, and as a result, prolonged interval and a decrease in number of frames displayed per second. The player doesn't love it. On the one hand, this is related to the variety of behavioral options available for the AI actor to choose from, and on the other hand, to the management of resources by each of them. In real-time grand strategy game, every state update requires advanced calculations aimed at faithfully simulating the behavior of the actor. During these calculations, it is necessary to take into account not only the state of the actor itself, as well as the relationship between it and the other actors. The set of parameters define the state of the given actor and its relations with other. It is necessary for the device to perform advanced calculations for all actors in the game. This forces optimization at the level not only of the algorithm and system architecture, but also in the use of the device's hardware system. So we can now point out the difficulties and risks while designing universal mechanics, not only for the grand strategy games, but in overall. Okay, lack of experience in designing this type of mechanics and all of the difficulties that came from this. We do not know how to estimate the time, how precise our estimation will be whenever there will be any delays. Moving to a business production model, not a game production model. From the side of requirements, proceed less creatively and more focus on technicalities, optimization problems, risk of not achieving technical parameters, risk of changes in the libraries in newer version of the Unity 3D engine, in example. That is, the engine will be so updated that we will not be able to use these mechanics for such a long time. Too short demand. People will not buy games that will have these mechanics, which will force a change in type of games created by the studio. So the whole tool, the whole universal mechanics will go to the trash and will never pay off. The needs to meet the legal requirements, you have to take care of all the licenses, plugins that were used in the production of your system. That's the easiest one from the list. So, what is the project idea of our Grand Strategy AI module system? Existing AI system overuse computing power and memory, causing players to experience a drop in the number of frames displayed per second. Our system is designed to optimize the performance of a variety of actor behaviors that are available in game and optimize the resource management of each actor. Optimization will be implemented at the algorithm level, system architecture, and in the use of the device hardware resources, making it possible to perform advanced calculations for all actors. In the game, which will allow frequent updates of the actor state that faithfully simulate its behavior. The main feature of GSAI is modularity, which makes it possible to develop the actions performed by actors, adding them and modifying them. Actions are handled by separate behavior submodule, making it possible to add and disable specific models for individual actor. It is possible to turn specific models on and off dynamically depending on the state of the game. The modularity of AI allows more complex calculations and more actions to be performed by the most important actors at the expense of memory resource taken away from the smaller actors, whose job is only to provide some background so the player not feeling it is alone in the game. Smaller actors will not perform certain actions, or they will be performed them in the simplified way. In summary, the main feature of AI model are compatibility with the Unity 3D engine, because the team just selected this engine. Simulation of multiplayer actors, behavior in real-time grand strategy games on mobile device. Ability to analyze project-defined dependencies between actors, reducing the demand for system resources of the target device by hiding a large number of actors into groups managed by the AI system. the possibility to dynamically change the demand for system resources thanks to the ability to change the submodel of actors' behavior. The possibility to change the overall behavior of actors with the passage of gameplay time and by random events affecting the dynamic of gameplay and simulating changes of the actor. Dynamic adaptation to the changing number of units in the game. So let's dig more into the artificial intelligence mechanism. The artificial intelligence mechanism module is a core component of GS framework. The AI system focuses on generating and simulating a large number of objects in real-time strategy games. The artificial intelligence module is responsible for analyzing the game state and the behavior of other actors based on certain determinants and the current game situation. This model selects the appropriate action. The choice of particular action can be influenced by the level of relations between actors, the resource of AI actor, the internal parameter of a given actor. In grand strategy games, as the gameplay progresses, the number and importance of individual actors, their units and resources change, which change the required CPU power as the game progresses. There can be an increase in the determinant for system resources. An increase in the number of actors requires more determinant analysis when taking actions. In order to solve this technical problem, a list of submodules responsible for specific gameplay element is assigned to each actor. The collection of modules make up the total behavior of a given actor. The list of submodules and the transitions between them will form a finite automation, like the Moore automation state machine. This type of structure makes it possible to disable or add more modules as needed. The AI module will not perform all calculations at the same time to prevent performance issues. So, as the complexity of the in-game situation increases, the module activates, changes, or deactivates the other submodules, making it possible to prioritize the calculation of other submodules. Expanding the list of actions and determinants is possible from the designer's perspective. The functioning of the AI model consists of the architecture model of the main model, the architecture model of the actor managed unit, the architecture model of the behavioral submodule, finite state machine responsible for the proper selection of behavioral submodules, algorithms for analyzing the state of the game and the states of individual actor. All in all, AI Manager is a model that manages all actors. Its main task is to activate individual tasks or submodules of artificial intelligence actors. The main issue here is to how inform such a manager about any actors in a given environment. In grand strategy project, there are usually a lot of actors that operate independently, and each of them individually can be taken over by the player. So let's take a look at the finite state machine diagram. So the finite state machine is an automation in which all allowed states are defined alongside allowed transition between them and condition for these transitions. You can see the diagram of finite state machine designed for a country actor. The diagram shows three states: neutral, in the top of it, this is the normal state, state of preparation for war, and state of war. The conditions for transitions between them are also defined. Each country is given a behavioral profile which includes a finite state machine. Each actor starts in the neutral state by default. After the start of the game, an analysis is performed on whether transitions to other adjustment states are possible. Each state updates all behavioral components based on the new parameter provided and actives additional submodules that are required by the state and deactivates submodules that are not. The finite state machine manager, that is a manager supervising the finite state machine, has a function to catch critical error messages occurring in the finite state machine and handle them by restoring the finite state machine to a stable state, neutral. The manager analyzes the state of each actor in-game and checks whether the state is currently used is correct. Transition condition is distinct cases may cause a given actor's state to be wrong. It is manager task to react to this event and reset the state of actors to stable one. Algorithms for analyzing the state of the game. The selection of algorithms for analyzing the game state and the states of individual actors and for selecting appropriate actions by actor managers depends on the needs of the game designer. The framework itself is designed to facilitate the integration of this algorithm with the rest of the system. This allows the optimization of GSAI framework which analyzes the game state and the behavior of other actors, and based on that, during the next decision interval, it selects the appropriate action. The determinants of selection and action are the level of relation between actors, the resource of the AI actor, the internal parameter of a given actor. Algorithms must comply with the supposed flexibility and modularity of framework. The user of the framework can choose to disable some modules so that they do not consume any computing resources. The developed algorithms for analyzing the state of the game and the state of individual actors are based on the divide and rule paradigm, Cesar, the indicated breakdown of problems into similar ones. The solutions of which will be consolidated allows for achieving a pessimistic computational complexity of the O notation O logarithm n, where n is the number of actors. Note that in the developed framework, the pessimistic algorithm complexity is more important than the average computational complexity, because one of the primary goals of our framework is to minimize the consumption of CPU power and the decrease in the number of displayed frames per second at the most critical moment, which are the most noticeable and most strongly felt by player. So we choose the time complexity over the memory complexity to prepare this algorithm and to optimize it. The use of the developed algorithms allow the artificial intelligence system to significantly reduce the demand of CPU power. Okay, so some words about the data container for the provinces. Subsequently, the system consists of data containers, a data structure with a task to store a set of data in an organized manner. In order to determine and generate provinces, it is necessary to set the size of the world in which the provinces will be generated. Objects that set the resolution of the world are stored in the data container containing the appropriate determinants to generate the map and the provinces. The class that creates the data container is scriptable object. No, it's a typical database structure object. Each generated mesh receives components of a mono-behavior type. So that is defined as an object in the game environment, transform component, mesh renderer, and the province component, which is the representation of the object of the provinces uses for the purpose of artificial intelligence calculations. All objects existing in the game also have a collision component, so we can easily, with using the Unity API for the physics, determine the interaction by the player with the world. So we can just throw the arraycast and check and determine what provinces are currently selected, then what country, and etc., like the objects like units or the buildings. The province data container manager is a data container with the purpose to manage the generated provinces. Its structure is presented in the diagram. The province data container here is the province manager, which has information about all the provinces that are in the game world. The container has implemented methods for adding new provinces, deleting current provinces, as well as retrieving provinces and their parameters for grand strategy artificial intelligence system. Provinces are created in the generation process. As a result of this mechanism, objects are created and added to a collection of hardset type. The specific type is selected by the optimization purposes. Some words about the dynamic parameters, what I mentioned before about. Base gameplay parameters are the core of all decision-making algorithms that are excluded by the current gameplay actors. All parameters are stored in the data container, which has several types of gameplay parameters collections. A gameplay parameter is a structure consisting of numeric variable as well as curve-driven variable. It also has a parameter name with which you can retrieve such a parameter and the type of specific what is affected. Parameters have additional properties by which the value of the test parameter can be subject to various mathematical operations, as well as it can be normalized in specific cases. An example of gameplay parameter structure is shown on the slide. A gameplay parameter consists of the type of modifier value, a curve value based on which the modifier is calculated, a percentage value that determines what percentage of the modifier is to be used, and additional settings that supports the formatting of the parameters so we can display some information on the GUI for the user. We have, in example, 3 types of parameters, A, B, and C. And in example, the designer wants to create the parameter A with the correlation of the parameter B and C. So the parameter B and C are correlated with the mathematical operation add, summary, and the summary of the parameter, the sum of the parameters B and C will be pointed to a parameter A. So the parameter A is a sum of the parameter B and C. We have we can choose between the add operation, sub operation, multiply, and divide. The task of Gameplay Containers Manager is to store parameters and manage them during gameplay. Its structure can be represented by a presented diagram. A parameter is a determinant that can be used in the computational process of the decision-making algorithm. The Data Container Manager, The Data Container Manager has a set of methods necessary to perform operation on a set of general parameters at the time of decision-making by individual actor. The data taken from the general gameplay parameters is vital. Before these parameters are used, they must be refreshed so that the values does not change during the calculation cycle. This is made possible by the General Parameters Container Manager, which contains methods that retrieve parameters and calculate them when needed. The main task of the The main task of the mediator is to transfer data between the data containers. The exchange of data due to the write cycle must take place daily according to the established mechanism of the time passing in the game. Data containers corresponding to specific domains of the actor's existence register to the main manager, which simulates the time change. Each container has parameters that correspond to a specific domain. Each parameter is updated based on the other supplied parameters from other data containers. For data containers to be updatable, they must have a method that updates the parameters, a method that we called on the update. Okay, so some words about the serialization. We use for serialization the reflection mechanism, and to make it more optimizing, we just cache the whole references map at the start of the game. And after this, when we press the save or when the autosave mechanism is working, we can easily make the quick save without the firing up the whole reflection mechanism, which is heavy and not so quite good when you want to not drop the frames per second. We also created the save field as an additional attribute, so we can serialize the primitive types, as well as we can serialize the more complex types like the value float. The value float is a type that represents the single parameter, dynamic parameter in the game. It has inside the list of the modifiers that is applied to it. So our serialization system was created by us, but now I think we will use some other solutions that are existing in the market. In example, the Cyanic serialization, which is quietly fast and really good, especially on the mobile devices. To create files, let's take a look at the Mediator system. The main task of the Mediator system is to transfer data between the artificial intelligence model and the environmental model. It has a set of methods for updating the state of a given mediator and its parameters based on the other parameters from other mediators and models needed for computational processes. These methods are controlled by a manager implementing a system that stores all possible mediators necessary for the AI decision-making process. The mediator system determines the cycle of carrying out the update process, parameter calculations, and the state which determines what update phase is currently being carried out. The diagram of the construction of the mediator system is a kind of abstract view from the top of the system. Can be seen currently in the slide by you. The mediator system manages all mediators existing in the game environment. It makes it possible to register new mediators as well as the deregistering them due to the situation and state of the game. After an update, all mediators, the AI model is updated as well, which prompts the appropriate update mechanism to make a decision. Thus, all the parameters that are required to determine the next decision of the individual actor, which will be sent to the artificial intelligence model. The process is carried out using the artificial country interface. A mediator system model has been created for data transfer between the artificial intelligence model and the environmental model, using classes and interfaces. Yeah, it's quite deep. To ensure that data can be transferred between models using messages sent from the mediator of one model to the mediator of the other model. Such a solution is the key to solving the problem of linking models to each other. The versatility of them, as well as the immunity to potential errors arising from the incorrect data or resulting from the non-existence of the necessary data to carry out computational processes. This problem is solved by a system called an inbox, with a task to hold messages sent by the sender model implemented in individual mediators until a request to a message is received by the receiver model. The inbox is an extension of the current data buffer, that is the artificial intelligence country interface, and is another mailbox interface. An architecture model of the manager that is responsible for the models, connections, and synchronizations of them. For all mechanisms to work, you need a mechanism that will manage them. For this purpose, we use a manager that manages the data update cycles and game time, because it contains collections of all mediators and the artificial intelligence model. It is a perfect place to implement this mechanism. Using a mechanism that will implement multiple threads, there may be a risk of data desynchronization, otherwise known as data race or data gambling. The way it works is that the thread do not know which of them will be first to complete of the action at the given moment, and that means that receiving the result at the wrong time can cause different actions, which is a program error. In critical situations, this can cause an error in the main loop of the program. The restart mechanism will react to that and restore the initial default data of the parameters, so the program now can run smoothly and stable. The flow of messages is done as follows. At the start of the system, an initialization process is started, in which two threads are started, one to handle and manage the mediators, and the other one to handle and manage the artificial intelligence system. During synchronization, in the message flow, the most important thing is the confirmation of the execution operation. So now, what is the usage of our system? GSAI can be used in all grand strategy games. We use it for Realpolitik from the Realpolitik 2, Realpolitik 3, Pang Wars, which is not typical grand strategy game because it is a turn-based grand strategy game. So after some modification of our system, we can easily implement it in the Pang Wars game and speed up the whole process. Now we are using it in the Realpolitik 3, and for the super heroes, some modules are used. In example, the artificial systems, the effects, the parameters system. So what is the observable benefits from using this our framework that we can describe to you? Reduction of processor computing power consumption by up to 60–70%. Reduction in determinant for RAM by minimum 20%. Reduction in AI system setup time by 30%. Yeah, we just measure the time that our designers need to set up something in the editor. Reduction in the time needed to design the basis of the AI system architecture is used to be speed up in the one project. Development of additional functionality of AI system will decrease from 20–30% per project. If we need and add a new mechanics, we should make AI for it much faster because we have the basis, we have the core, and now we can just increase our possibilities of our games. So I think it's all from me, and thank you very much for your time, for your patience, and have the nice of the rest of the event days. So is there any question about the presentation or overall with the game development as a programmer? Yeah?
Hello, I have a question about what you described as changing the performance based on how much stuff is doing at the same time. So you are affecting difficulty of the game based on the hardware the game is running. So the player is running over on smaller, weaker hardware, when some more of the AIs are running more performance efficient AI. And this is causing them to be weaker, so they probably get eaten by others, and this probably affects the gameplay. Is it correct, or do we have something to handle it so on every PC, on every hardware, the game is running the same way, and performance is not affecting the decision-making process?
Yes, it's especially noticeable in the mobile devices, because the mobile devices doesn't have the GPU component, and we use some calculations we perform on the GPU systems. It is a computational shaders, if I mention correctly in Unity. It has name as it. In the mobile devices, we doesn't have the GPU component, so we must use the job system for it, and it is noticeable slightly poorer performance than in the PC, and it is normal. I think it's something that we can expect.
Yeah, but I was mostly asking about, does it change like how the game is played? Like if you play on high-spec device and low-spec device, you do the same simulation, and you end up with different results due to more agents being on low AI.
No, in all devices there are the same division between the important and low important AI actors.
Okay, thank you.
Okay, so, do you have any more questions?
So thank you very much once more, and have a nice day.